I am going to speak about the topic Newton's third law. To every action, there is always opposed and equal reaction, or the mutual actions of two bodies upon each other are always equal and directed to contrary paths. If two bodies exert forces on each other, these forces are equal in magnitude and opposite in direction. If one body exerts a force on a second, the second exerts an opposite and equal force on the first. This term, action and reaction, often quoted because they stem from Newton himself, may be misleading to students in that they might imply cause and effect, but in fact either force can be the action or the reaction, and the force can act simultaneously. Newton's third law: if body A exerts a force F on the body B, then body B exerts an equal and opposite directed force on the body A. The force lie along a line joining the two bodies. When does Newton's third law apply? Newton's third law applies to gravitational and electrostatic forces and to elastic forces between two objects connected by a straight spring. It does not apply to forces that depends on velocities of the interacting objects. Then here are some of the examples for Newton's third law of motion. Other difficulties with the third law: when two balls collide or when a scatter pushes against a wall, we have a contact between two objects that are exerting forces on one another. In the case of gravity acting on, say, a book resting on a table or a ball falling towards the earth, we have a non-contact force. With gravity, we have another potential source of confusion. It is easy to see the acceleration of a book towards the earth when the book is not supported by a table, but we can't detect the acceleration of the earth towards the book. The force of the book on the table is the same as the force of the earth on the book, but because of the very large difference in masses, the acceleration of the earth towards the book is not detectable. Two bodies exert equal but opposite forces on each other, that is N equal to mg. The scope of this force is not limited to interactions involving physical contact. This law appears to apply only when two bodies come in contact. But in reality, the characterization of force by third law is applicable to all force types. This requirement of pair existence is equally applicable to force like electrostatic or gravitational force, which can act at a distance without coming in contact. Let us consider the force between two charges Q1 and minus Q2 placed at a distance r apart. The magnitude of this electrostatic force is given by F equal to Q1 Q2 divided by 4 pi epsilon naught R2, that is R square. Deduction of third law from Newton's second law. We have pointed out that action and reaction forces are external forces on the individual bodies. However, if we consider two bodies forming a system of two bodies, then action and reaction pairs are internal to the system of two bodies. The forces on the system of bodies are epsilon F equal to epsilon F internal plus epsilon F external. If no external forces act on the system of bodies, then F external equal to 0. This is possible when internal forces or pair forces of equal magnitude which are directed in opposite direction. Forces appear in pair. In this, internal forces F12 plus F21 equal to 0. The action and reaction forces are therefore equal in magnitude but opposite in direction. Clearly, third law is deducible from second law of motion. The important point to realize here is that action and reaction forces are external forces when considered in relation to individual bodies. Each of the two forces is capable to produce acceleration in individual bodies. The same forces constitute a pair of equal and opposite internal forces when considered in relation to the system of bodies. In this consideration, the center of mass of the body system has no acceleration and the net internal force is 0. Thank you.